Thank you, Dr. Houston. And thank you for having me today. I must admit I feel a little out of place. I'm the only electric utility, electric generating company that appears to be here today. Also around the company, and probably for the last 20 years, the better descriptor for me is Dr. Doom, because I tend to look out to the future and tend to look at the impacts that a lot of these technologies are going to have on the energy and utilities business itself. So I also realize that it's after lunch and the energy level's down, so I'm going to spend a minute about ENMAX's business. We have two distinct businesses. We own and operate the regulated wires within the city of Calgary under the old franchise utility model, rate of service type aspect of things. We also are heavily involved throughout the province in the unregulated part of the business, both as a merchant generator and as a retailer of electricity and gas. So I'm a large consumer of natural gas, both to retail to end consumers, as well as what we burn in our gas power plants that I'll talk about in a moment. We also are pretty heavily involved in wind and also microgeneration. Some statistics: about 1,700 employees, about 761,000 metered customers. We sold about 8,400 gigawatt hours, or about 13% of the electric market, to customers in 2011. We've got about 2,000 megawatts of generation I'll talk about in a minute. Consolidated revenues last year of $3.1 billion. Total assets a little over 4.3. And we invest about $550 million a year either in generation assets, distributed generation, or transmission and distribution infrastructure. A couple of other statistics: Corporate Knights Best Corporate Citizens, and one of the Alberta top 50 employers for the last 5 years. So let's look a little bit at generation, and I want to first start with the big transmission wires that you see there. I'm certainly interested in the ceramic wires or anything from a superconducting perspective, because reconductoring those things are much easier than trying to acquire new right-of-way, and due to the not in my backyard phenomena that we find in trying to put these things through new distances, etc. We own the output of several purchase power agreements for coal-fired power from several of different power plant owners. I'm also interested in the spray-on aspect of things from an erosion and corrosion perspective, because coal is probably one of the most abrasive environments in the world when you have to crush it and then blow it into a boiler. And more important, you have to burn 100 tons of coal to get a megawatt out the back end of a power plant. And about 60% of that 100 tons is ash, so I've got to dispose out of another very erosive, corrosive substance out the bottom of a boiler on an ongoing basis. So very, very interested in following these technologies with regard to that. We've also got an issue with regard to the stuff that goes up that stack. Not only CO2, but SO2, SOx, a whole bunch of metals that we really don't like to talk about, of heavy metals that cause respiratory effects, and certainly mercury, and there's been a lot spent on these plants from a pollution abatement perspective. Also on the transmission side of the business, we use sodium hexafluoride as the gas to open the high voltage breakers. Those of you that aren't familiar with sodium hexafluoride, it's probably, the numbers range between 60 and 100 times more damaging to the environment than CO2. So we have quite a few of these large breakers scattered throughout the transmission system in Alberta and across the world that we use. So monitoring these gases from a leakage perspective are also very important. At one of the breaks today, we're also interested in the infrared detection over a wide area, because when you walk around these thermal plants that have a steam turbine on the back end, you don't dare to go into an old power plant without carrying a broom. Anybody know why? Anybody want to guess? Should I pick on somebody? High pressure steam. Can't see it. Can't hear it, but it'll literally cut you in two if you walk into it. So I was taught this technique when I started in the industry about 1968 from an old power plant operator on a coal-fired plant. taught me never go in a plant without a broom. And I asked him why. And he told me that. I said, "You've got to be kidding." He said, "Nope, come on tour with me. You're leading." I said, "Not after you told me that." So just swing the broom in front of you and you'll find it. And I did, and he cut the broomstick in half, just with a sweep through it like that. So high pressure steam is a big issue that these acoustic measures are very important. Predictive maintenance in these plants and on transmission systems are very important. It was interesting to see your graph on the adoption rate of technologies. We in the energy utilities business are probably off your scale with regard to how the industry has changed. The industry fundamentally hadn't changed in 150 years, but we're starting to see a lot of technologies that are going to have a huge impact on our industry and our business. Continuing, we also own about 218 megawatts of capacity with wind turbines down in the south part of the province. There are issues with these things too, mainly from the standpoint, the big problem with these things, particularly that vintage, is the gearbox that basically connects the shaft, that the big propeller on the front end or the windmill on the front end is basically coupling that to the generator on the back end. You got a whole bunch of oil up there. You hate heat. You hate a whole bunch of other things. You don't want the front bearing to seize. If you do, you wind up with a fire about 300 feet in the air, and there's no rural fire department that can squirt water from their grass rigs to put one out. So they typically burn off the mast and fall to the ground, usually setting a nice grass fire for folks. So we have issues with these from a predictive maintenance and from an oil containment. You don't want that oil to spill and get out on the ground. So we have issues there. We're building an 800 megawatt combined cycle gas plant, about 65% efficient down in the southeast quadrant of the city. These are pictures, let's see, that's probably about 3 months ago, given I was down there yesterday. They still got the heavy crane in the middle erecting the heat recovery steam generators that you see right here. The combustion turbines set out on pedestals right here. So that will be the largest combined cycle gas-fired plant in the Alberta province. We too have emissions from that, SOx, NOx, and CO2. Not nearly to the extent that we do on the coal-fired plants, but we certainly have emissions that we have to worry about there. Burns a tremendous amount of gas. From an environmental perspective, we are equally concerned about water and water availability for these thermal plants over the long haul. Therefore, this facility, as well as, not that one, that's our peaker up at just northwest of the airport, but the Calgary Energy Center, both of these facilities use wastewater from the city of Calgary for cooling the turbine and the condenser to condense that steam out. So last but not least, our district energy facility basically providing hot water services for both heating and cooling on an energy loop in downtown city of Calgary itself. What I don't have pictured here is to date we've installed about close to 500 individual systems of solar photovoltaic on top of individual customers' roofs in a cooperative that we have with CCEMC with regard to the deployment of these technologies from a carbon offset perspective. The micro wind offering that we've got for residential and for rural type communities isn't seeing the take-up that we had anticipated, mainly because you got to be in the southern part of the province in the wind regime to get that to happen. And when you do, this is what they're expecting you're going to come build on their property because they want the royalties associated with that crop that they're growing out of the ground down there. So a little bit about our business and what we're into. But what I'd really like to spend some time talking to you about, which is where I see things and where we spend an awful lot of time, is on this chart, and that is that we're in the middle of a major global transformation. And it's all enabled by telecommunications, computing power, and nanotechnology. And I have to pause there for a moment because coming to work this morning about 20 minutes till 6 was an interesting feature on Canadian Public Radio, rebroadcast from BBC, about the persecution of gays in Iraq and the systematic eradication that's taking place there because of a dispute between the purists from a Muslim belief perspective that happened to be tied up with the government. So many of the people's rights things that we're fighting here are being fought in every other culture around the world. We would have never heard about that before had there not been the ability via communications to interview those people and get that information out. And that's how the world is fundamentally changed. Nanotechnology is a fundamental enabler of all this, and I firmly believe it will solve a lot of the issues that are out there today. But it results in this global connected economy, a shift in the power axis from the G20 to the non-G20, questionable long-term sustainability at many levels. UN population report last year. Anybody seen it? Who? Anybody seen it? What's it say? Okay. Gives you a series of scenarios. Where are we today with the global population? 7 billion. Current birth rates. Where do you think the population is by 2100?
U.S.
Pardon?
U.S. or world?
World.
About the same as now, 20 billion.
27 billion. Think we can sustain 27 billion people on this earth? I don't think so. Check some of the raw materials that are out there today. The availability of iron ore. More importantly, the availability of known reserves of phosphorus. When do we run out of phosphorus with 7 billion people on the face of the earth? About 10 years. Where's the majority of the phosphorus today exist? In the rivers and the estuaries downstream of wastewater treatment plants. Can you imagine the environmental impact statement? We're going to go dredge the river to recover the phosphorus? That will be an interesting one to get through. If we provide a reasonable level of sustenance and living for the population of the world, where do you think the world population is in 2100? No. The population of the world in 2100, if we can get the world to a reasonable level of access to clean water, sustenance, a level of living, and education. Because it changes the birth rate.
I noticed.
4. Now, it challenges all, because that challenges every economic model any of us have ever been exposed to. We're talking about 3 billion less consumers on the face of the earth by that point in time. And that is this transformation that we're in the middle of. Some argue we have started the next transformation that will take less than a year. So, average life expectancy for a female today is? Pardon? 76. A male?
65.
74. So my wife did right by marrying a younger guy. We'll probably pass away at the same time. The prediction from the U.S. Department of Defense, from 2 perspectives, based on the advances in health care at the nano level, if you can live 10 more years, life expectancy goes up 30. So you go from 74 to 104, from 76 to 106. If you think we've got problems with social programs today, we're going to have another aspect of things. And I want to retire at 50 when I'm going to live to 100. Don't think that model works anymore either. So that is a huge change that's coming. If you can live the 40, life expectancy goes to what? Infinity. Another big issue that's not factored into the UN population. The other trend is by 2030, 1 in 3 workers in the work environment will be a robot. And we're seeing that phenomena today. So we have to take that into account when we start to look at all these models, which is the bottom line for why we track and trend and try to do scenario planning. because it's just too volatile out there today to be placing billion-dollar bets on power plants that we're hoping are going to last for 40, 50 years as they have in the past. So we spend a lot of time as an executive team looking at that. You want to see what happens from a technology and an overall aspect of things? If you go back and you looked at what 1 kilowatt hour of solar PV cost in 1978, it was about $5. If you look at where we are today, we're a little north of 20 cents. 2015 will be down in the 10 or 11 cents range, and that is at grid parity in every jurisdiction in North America, based on developments coming out of labs, based on developments coming out of nanotechnology, etc. This is a game changer. Feed-in tariffs no longer work in Germany because installed solar in Germany today is cheaper than what you can buy the electricity for on the grid. Therefore, people are installing solar to take cost out of their overall aspects of things. Last but not least, in thinking about this talk today, I ran across this chart in Living on the Fault Line by Jeffrey Moore, why technologies seem like they fall off a cliff at this space. And the phenomena here is you go from the technical visionary that had identified and invented the technology to someone that says there's got to be a way to commercialize this. But you get on the consumer side of wanting to adopt this. Our first question in the energy and utilities business is, where's your reference customer? Where's your second reference customer? Because if you can't show me 3, I'm not interested. I'm tried and true. I'm not bleeding edge. And the minute you get to that, you get this awful tornado takeoff that takes place. The key to crossing this chasm is you have to shift the entire thought process of the company from the invention side of things to making it a product, marketing it, selling it, and taking it to market. So when we evaluate technologies, it's not just for the disruption in the business. It's also looking at their long-term viability in the marketplace before we make those kind of bets. So it's been a pleasure to be with you today, and we'll take a question or two.